connecting sides, angle and circumradius of a triangle. Once we have circumradius of a triangle, it means the radius of the circumscribed circle of that triangle, meaning the triangle is inscribed in the circle. So assuming you have a circle and a triangle, so assuming triangle A, B, and C is inscribed in this circle, let the radius of the circle be R. So if I take the radius of the circle to be R, so I want to get the formulas relating the sides, the angle. You know the sides here is A, the one here is B, while this one is small letter C. So as far as this is the circumradius, you know that if I extend this is also the radius. Maybe if I call it D. So you see that OD, if the center is OD, is also the radius, because this is the center. And again, you see that 2 radius is the diameter, so BD is the diameter. So meaning that if I trace down this, we have angle 90 by inscribed angle theorem. So I'm saying that angle A is equal to angle D by Bow's theorem. Bow's theorem, that's angle at the circumference are equal. That's this angle and this and this. Or angle in the same segment are equal. So that's Bow's theorem from it. So from this triangle, so in triangle BDC, you see that, remember, this is our hypotenuse is 2R. Why this is our, remember, the angle given is this. So this is the opposite. You see that sine D is equal to opposite, which is A, over hypotenuse, which is 2R. So, but I told you that A and D are the same, so sine A instead of D is now A over 2R, which implies that A over sine A will be 2R. You see the logic? So this comes here, this comes here, making 2R the subject of formula. But from sine rule, A over sine A is equal to B over sine B equals C over sine C. So this is sine rule. So which, remember, this is this. So this, they are all equal to 2. So that's what we are looking for, the relationship connecting the in radius. That's what we are looking for, a relationship connecting the circumradius, which is R. So R is the circumradius, while A, B, C are the sides, while angle A, B, C are the angles. So you might be given this, you're asked to find any of them. Example, if you are given this circle, so the sides are root 3 and 3. What you notice that I can relate the side that 3 is the same thing as root 3 times root 3. So with this, we now see that the triangle inside is a 30, 120 triangle, because the ratio of the side is this, 1:1 is to root 3. that the one facing, if the one facing the 30 degrees are each xx, the one facing 120 is x root 3. So without wasting time, this is root 3, this is root 3. So this is root 3 times root, so x is root 3, so this should be 120 is 30. Is also 30. So using the formula we just derived, that 2 radius is always a over sine a, b over sine b, c over sine c, c over sine c. So we can label this as a, b, c. But remember, we're just taking one of the equation. I'm taking this. So we have 2 radius. Well, so our a is root 3. Our angle is sine 30 degrees. We are looking for r. So r is root 3 over 2 sine 30. So which is root 3 over 2 sine 30 is half. So our answer is root 3. So option A. So it's very simple.